Hello everyone, and today I will show you how you can change your bases. But before we will do this, you need some general knowledge in order to see how beautiful this process is. First of all, you need to know what is coordinate vector. For the rest of my lecture, I will write it in such way. The coordinate vector is the representation of vector as an ordered list of numbers which describe vector in terms of particular ordered basis. In other words, if you have B basis, this means that B is some ordered list of not collinear vectors, and our vector V in respect of basis B is a list of numbers alpha 1 till n, which means that is equal to such equation. So this is just a simple definition of basis, and the vector which is represented in this basis I will name as coordinate vector, and it will be written as in this way. Okay, with coordinate vector, the next definition we need is transition matrix. Transition matrix specifies the transformation from one vector basis to another one under the change of basis. In R3, we have some vector V with such coordinates. Now we have two different bases, for example basis A, B and A. In basis B, our vector has coordinates like Z, and in basis A it has something like Z. And transition matrix specifies transformation from this basis to another. That means that it shows how we got this coordinate vector from that one by changing the basis. Now I will teach you how you can move from basis A to basis B in a few steps. First one is each vector we need to represent, each vector from basis B we need to represent in basis A. We will get something like this. Because of the fact that A is basis, this means that each vector can be represented. Next, we will represent this vector system as a matrix, and as a result, we will get a transition matrix, which multiplied by every vector in basis A will give us vector representation in basis B. We get this equality from our third step. If we make it less general, we can get such equality where V is a vector in Rn. This is clear because A is already transition matrix. If we want to show this vector in Rn, because each vector in A is represented as a vector in Rn.
So if you understood what Yura have explained, you don't need the rest of the video, but if you don't, we will start with a simple example. Suppose we have such vectors v1 and v2 with coordinates, and vector A in basis B with such coordinates. What does it mean? Well, we have here a picture. We can see there that v1 and v2 define the plane, and vector A in basis B lie in our plane too. And we have to find the coordinates of original vector A that can be just intersect our two vectors, so it doesn't lie in our plane. So basically what we have to do is multiply our matrix, which is formed by our vectors, by our vector A in basis B. That's the result of multiplication. You can check this, and thus we will get coordinates of original vector A, which is 3, 14, and 17. So suppose we want to transform our coordinate vector with respect to basis A in new basis B. What we have to do, we set up matrix from our vectors from basis B and make its inverse. Why we make inverse? We have such formula. If we want to get a coordinate vector with respect to basis B, we multiply our vector in R3 with inverse of this matrix. So we made inverse and multiply it by our vector V1 from old basis. And now we got V1 in basis B with such coordinates. In the similar way, we do the transformation of V2 and V3 to new basis B and got such coordinates. Now we have to transform our vector x with respect to basis A in basis B. So now we form our matrix from V1, V2 and V3 in basis B. This is such matrix, and multiply it by our old coordinates of x, and now we got a new coordinates of vector x with respect in basis B.